question is, the prismatic bar is carrying only an axial force. The two planes on which the normal and shearing stress incline to the axial force at an angles. It is a direct question and it is going to make an angle of pi by 4 and 3 pi by 4. Option B is correct. The question is, if the internal radius of the hollow shaft is 1 by 5 times the external radius. So internal radius r is equal to 1 by 5 times the external radius r. Then the ratio of torque carried by the hollow shaft, hollow torque, solid shaft, we have to find out, of the same cross-sectional area and subjected to the same maximum shearing stress. The condition is given as cross-sectional area is same and maximum shearing stresses are same in case of hollow and solid. So we know the condition. If we consider it as x, then we know the condition T hollow by T solid is equal to 1 plus x square by root of 1 minus x square. So 1 plus 1 by 5 square by root of 1 minus 1 by 5 square, that is equal to 13 by 5 root 6. So option B is correct. Here the question is, which of the following method is employed to manufacture pre-stressed concrete sleepers for the railways? The sleepers which we are using in railways, which type of sleepers or which type of pre-stressing that we are applying is pre-tensioned pre-stressing. Usually we apply for the sleepers in railways. So option B is correct. Question is, according to Whitney's theory, the maximum depth of concrete stress block in a balanced RCC beam section, the effective depth is D. So by Whitney's theory, the maximum depth is 0.537 D for a balanced section. So option D is correct. Question is, water is flowing at a rate of 0.1 cc per second in an upward direction. So the discharge is given as 0.1 cubic centimeter cube per second. And the sample with permeability K is given as 2 into 10 to the power of minus 3 centimeters per second. And the thickness of sand sample is given as T is given as 10 centimeters. And the sectional area A is given as 50 centimeters square. The effective stress at the middle of the sample. We have to find out the effective stress at the middle when the flow is in upward direction. So we will find out the I value. Q is equal to A, we know, that is equal to A into K I. I is equal to Q by A into K. Q is equal to 0.1 by A is 50, K is 2 into 10 to the power of minus 3, that is equal to 1, upward gradient. So we know that the upward effective stress upward sigma prime is equal to Z is at the middle, whether it is from the top or bottom, it is going to be 0.05 centimeters, meters, 5 centimeters, that is 5 centimeters. So Z into gamma submerged minus Iz gamma W. So gamma submerged, we know that gamma saturated minus gamma W, that is equal to 2 minus 1 ton per cubic meter. Z is equal to 0.05 meter. I is equal to 1. By substituting these values in this equation 1, we get sigma prime is equal to 0.05 into gamma submerged is what? 1, minus I is what? 1, Z is 0.05, gamma W we know 1 term per cubic meter, that is equal to 0. So the effective stress is going to be 0. It leads to the quicksand condition where the effective shear strength is equal to 0. Question is, a saturated stiff clay has a unit weight. Unit weight gamma is given as 2 grams per cc, and the unconfined compressive strength S is given as 2 kg per centimeter square. But the cohesion S by 2 is equal to 2 by 2, that is equal to 1 kg per centimeter square, that is equal to 1000 grams per centimeter square. The depth of tension crack Z is equal to 2c by gamma root Ka. We have to find out Ka. For a pure cohesive clay, Ka is 1 minus sine phi by 1 plus sine phi. We know active earth pressure coefficient phi is equal to 0 for clays. So Ka is equal to 1. So this term is going to be 1. Z is equal to 2 into C is 1000 grams per cc by gamma is 2 grams per cc. So 1000 centimeters, that is equal to 10 meters. Option C is correct. Question, we have to find out the flow rate through a 3-meter wide concrete line rectangular channel having a slope S is equal to 1 in 10,000. The depth D is equal to 1 meter and width of 3 meters, depth is 1 meter. So perimeter is going to be 1 plus 1 plus 3, that is equal to 3, 4, 5 meters. Area of the rectangular channel is going to be 3 into 1, that is equal to 3 square meter, or is equal to A by P, that is equal to 3 by 5.6 meters. So by using Manning's roughness coefficient, velocity we can know as 1 by n r power 2/3 s to the power of half. We know S, we know R, we know N. We can find out V. 1 by 0.012, R is 0.6 power 2/3, S is 1 in 10,000 or 1 by 2. That is equal to 0.6 meters per second. So the discharge Q is equal to AV, that is equal to A is 3 into 0.6, 1.8 cubic meters per second, that is 1.78. Option A is correct. Question is, the pipe wall of roughness coefficient K for a new cast iron pipe is given as 0.26 millimeters. The roughness coefficient of initial new pipe is given as 0.26 millimeters. After 3 years, so time is 3 years, the service of 3 years of service, it becomes 0.41. So KT is given as 0.41. So we know the relationship that KT is equal to K naught plus alpha into T. So KT we know 0.41, K naught 0.26 plus alpha T is 0.41. From this equation we can find out alpha, that is 0.05 millimeters per year. Sorry, it is 3 years. So what we have to find, what will be the value after 18 years? We have to find out a T is equal to 18 years. So KT is equal to 0.26 plus alpha is 0.05 into 18, that is equal to 1.16 millimeters. So option C is correct.